Welcome everyone. Thanks for joining us for Mrs. K's way of solving missing angles using algebra. This is part one of the two-part series. You can look below you and you can see that I have the link to part two below. We're going to be using part one we're using our worksheet practice 6.2 and we're going to be looking over problem number 13. So for problem number 13 in practice 6.2, we want to try to find the value for k. Those are our instructions. And if we look at the image below, we see we have 1, 2, 3, 4 different angles that share a common vertex in the center. So because these guys all are around a common vertex, I know that if I were to take this angle plus this angle plus this angle and this angle, that it would create a circle. And I know that if I have 4 different angles around there, then those 4 different angles are going to add to 360 degrees, which is awesome for us because we know that all 3 of those are going to add to 360 degrees. We'll use that information next in order to find our value for k. So as we stated on the last slide, we see that our 130 degrees plus our 3k plus our 5k degrees plus our 2k degrees, all of those, since they share a common vertex, will equal the sum of 360 because a circle has the degrees of 360. So what we want to do is we want to create a summation or a equation where I'm summing all 4 of these to equal my 360 degrees. So if I take 2k plus 5k plus 3k plus 130 degrees, I should equal 360. So my equation will be just that. I have 2k plus 5k plus 3k plus 130 is equal to 360 degrees. Now, I did warn you that we are going to be using algebra in order to solve this. However, we can also think logically. If we were to take 2k's, another 5k, and another 3k, how many total k's would we have here? So we're going to be combining the like terms of all the different k's, and we're only worried right now about this left side. So I'm going to combine my different k's, and I know that 2k plus 5k plus 3k gives me a total of 10k plus 130. And we know that that still will equal 360 degrees. Now, this is really nice because we now have created a two-step equation. There are different ways we can solve this two-step equation, but since I am trying to find my k, I am noticing that if I were to look here at my original, I know that if I'm worried about these different k's and this 130, well, since I know that there's 360, I'm going to take away 130 degrees from that 360 to see how much I have left. And algebraically, how we would show that is we would subtract 130 on both sides. So when we do that, and remember the sides are determined on the different parts of the equation, so left versus right. So we're going to subtract 130 on the left side and 130 on the right side. And we know that 130 minus 130 will leave me with 0, so I can know that that's going to equal 0. And then 360 minus 130 will give me 230. So I know that 10k is equal to 230. Now, the great thing is now I did a two-step, I'm left with just a one-step equation. And I know in order to solve for k, I want to do the inverse operation, which here shows multiplication. So I'm going to divide both sides by 10. That way, I'm left with 1k is equal to whatever 230 divided by 10 is. Well, I can see that both of these I can cross out the zeros, and I know that the value of k is equal to 23. And since I know that my k value is equal to 23, I can actually go back in and solve for each of these different values. So I would know that 2 times 23 would be a total of 46 degrees. My 5K would be 115 degrees, and I would also know that 3K would be 69 degrees, since all we did was take our different K value of 23 and we plugged it in for the K. Now, the problem just asked us to solve for K, so our final answer here would still just be 23. Thanks, guys, for watching part 1. Hopefully you can take the time to watch part 2 and solve more complex angles using algebra.